So to formalize what we just talked about in the last video, where we were talking about the um, what the x values of the local maximums or minimums, how they showed up in the derivative, those are called critical numbers, right? So right here at the top of the page, they say that at each relative extremum, the derivative is either zero or does not exist. The x values at these special points are called critical numbers. Figure 3.4 illustrates the two types of critical numbers. Notice in the definition of the critical number c that has to be in the domain of f, but c does not have to be in the domain of f prime. So let f be defined at c. If f prime of c is equal to 0, or if f is not differentiable at c, then c is a critical number of f. So maybe like end of February, we were talking about differentiability. And the basic idea was just this. Wherever you have a horizontal asymptote, um, a non-removable discontinuity, or where you have a cusp in your graph, something like this in figure 3.4, I would call that a cusp, because notice how it's like that sharp turn, where the limit exists, but if I talk about the slopes coming in from the left and the right, the slopes are definitely not going to be the same when we get to C. That's the cusp. That's a place where I would expect to find a critical value. So whatever C was, C would be a critical value at that point. So when we had the absolute value, that's why x equals 0, 0 was a critical value because that's where you had that cusp turn on your graph. Or, remember how I kept asking you guys to find horizontal tangent lines and those x values? It was a lead up to this moment because I knew we were going to talk about critical numbers, so I just want to make sure you were comfortable with those skills of how to do that. Because now that you have those skills, we're just going to employ them and interpret our results. And more importantly, I kind of want to wrap this up before I make another video explaining how to actually do this math. Theorem 3.2 states relative extrema only occur at critical numbers. So if f has a relative minimum or a relative maximum at x equals c, then c is a critical number of f. And then down here, they kind of give you a proof, and their proof is more like, well, consider that it wasn't equal to 0, right? So like consider that we don't have a differentiability or that it is differentiable, but the derivative is not 0. And it's kind of like proof by contradiction. So if you guys want to talk about that, feel free to chat me up during office hours. I will definitely get that with you. But next video we'll talk about how to actually do some of the math now that we have it. Specifically more focus on the on the extrema using the extreme value theorem.